All right, so part C. This one, there are two ways to solve this. Now, as you know, you should be lazy. And lazy people start off with conservation of energy. That being said, I'm going to not be lazy to start off with. I'm going to show you the long way to do this with force and kinematics. And then I'll show you the quick way to do it. So let's take a look at this. If the larger block slides a distance of d before coming to rest, determine the value of the coefficient of kinetic friction. That means it's going to be moving. It's not going to vary, and it's going to be moving between the block and the surface on which it slides. So here, right here, this large block is going to be going that way. And then it's going to come here, or v equals 0 at the end. And its initial velocity is 2v naught. So let's first look at this. We want to find, what does it want? Coefficient of kinetic friction. Well, let's look at what that is. The force of friction is equal to the coefficient of friction, how frictiony the surface is, and the normal force. All right. So let's solve that for coefficient of friction. Would equal the force of friction over the normal force. All right. Now, we need to draw a free body diagram. Let's figure out how this would work. Got your weight. Okay, you got your normal force. And you have your force of friction. Now, which way is this accelerating? Remember, it accelerates in the same direction as the net force. So your acceleration, your only force that doesn't cancel each other out here is going to be your force of friction, so your acceleration's that way. So let's keep that in mind. Well, let's see. So force of friction, normal force. Well, we know the normal force here, because these two balance each other out, it's only accelerating in that way, that the magnitude of your normal force is going to be the magnitude of your weight on that. All right. So this is already taking a long time. Let's see. So we got that. So we can say that mu is, okay, we got the weight. So how to find force of friction? Well, we know force of friction, since that's the only way it's accelerating, is going to be the net force. So remember, net force equals mass times acceleration, and then the big force or the accelerating force, you know, subtract the resisting force if you have one. That also gives you net force. Well, here you've only got one thing that's, you know, causing the net force. That's the force of friction. It's going to be mass times acceleration. Okay, we're getting close. We have the mass, but how do you find the acceleration? Guess what? The worst, right? So we don't know the acceleration. That can be tricky. We don't know the time. Your initial velocity, 2v naught. Your final velocity, it stops, is 0, and your displacement is d. Okay, so which equation can we use for this? Okay, so I wrote these up here. All right, so let's look. We're looking for acceleration. They all have that in there. What don't we have? We don't have time. So these two go away. That makes it easy. We need to use this one. So down here, I'm going to go velocity final squared equals velocity initial squared plus 2 acceleration displacement. Final velocity is 0. Therefore, negative velocity initial squared plus, or up equals 2as. We're going to divide that by 2s. They just divided 2s. So acceleration equals velocity initial squared. So 2, and this would make sense because your acceleration is going to be negative, because this is when you see that negative, it doesn't go away if you square things. So I'm going to plug in for my velocity initial. It would be 2, which is 4v naught squared. It's going to be negative, and that's all going to be over 2d. All right, we're almost there, I think. So let's go back up. So force is mass times acceleration, force of friction. I'm going to move that over here. So force of friction equals your mass of the larger block, so 1.5 m times 4, and I'm not going to worry about I'm not going to worry so much about the negative. It's going to be 4v naught, because we're just looking for the coefficient of friction. 4v naught squared over 2d. And I guess I could have canceled these out. So yeah, I guess that would be 2, 2. So this would equal 3 naught squared over D. I think that's right. So that's your force of friction. And your normal force was mg. So sorry, I'm kind of going all over. See, I'm drawing the arrows. If you ever do this, draw arrows so people can see what you did. So coefficient of friction would be 3 mv naught squared over d divided by the normal force. So that's going to go divided by, it's going to go to the denominator. So I'm going to put mg. So we got that. And this is going to give you 3v naught squared over dg. I think that's right. Let's see. Okay, so I'm looking at this and I see the correct answer, and that's not what I got. I got close to that. I messed up my math. Let's take a look at why I did that. So, on this, and remember this is the long way, so it looks like for any relationship between the force of friction and the acceleration of the block, so your net force. So see this right here? That's my first point. All right. For a correct kinematic equation relating to the distance, okay, so for this kinematic equation, that's 1 point. See, I've already got half of my points just by writing down equations. Okay, for using the correct initial speed of the block. All right, I did that because I got my 4 here, so that's going to be 1. For substituting in the first equation above and for the correct answer. So here's what I did, I think. Okay, so I needed to, you know what, on the weight, I did not put 1.5 for the mass. So 3 divided by 1.5 would be 2g. I would have gotten 3 out of the 4. So, because this would be a point right here, this one goes with that. So I would have gotten 3 out of the 4. So that's still pretty good considering I kind of did this really quick and, you know. But see how much this is? Just, it's too much. It gave me plenty of time to make mistakes, or plenty of places to make some mistakes. That's not good.